Hi, and welcome back to another LeetCode easy problem. Today we're looking at LeetCode 3432, count partitions with even some difference. And we're approaching this problem interview style. And we are going to practice the interview process, speaking while we are coding and explaining what we are doing, more so than trying to explain you what the solution is. But hopefully we'll come up with a solution regardless. I have not tried this before, so first time doing it. So I've given an integer array nums of length n, and a partition is defined as an index I where I is between 0 and n minus 1, splitting the array into two non-empty sub-arrays. Non-empty, okay. The left sub-array contains indices from 0 to I, and the right sub-array contains indices from I plus 1 to n minus 1. So return the number of partitions where the difference between the sum of the left and the right sub-array is even. Cool. Next question would be to the interviewer, okay, is nums, does it always contain elements? Can it be nil reference? And what kind of numbers are we going to have in there? How many numbers are we going to have in there? And all this kind of stuff. And since there's nobody I can ask, I can scroll down to the LeetCode constraints and get the answers that I'm looking for. So here we know that nums contains at least two elements, and all of the values are going to be positive numbers greater than 0 in it. Nice. And yeah, so let's have a quick look at an example, even though we might already have an intuition of how we want to solve this. Looking at an example is always a good thing to do. If the interviewer doesn't give you one, you can ask for one, or you can make your own up. Here in LeetCode, we're given examples. So here we have an array that contains 5 numbers, and we now should compute how many splits can I make so that I get how many different left-right partitions can I have in the array where the difference between them is an even number, right? So I would probably just add up all the values and then iterate with an index over them and increasing the sum of the left sub-array at the left partition and decreasing the sum of the right partition. So let's say we do that. So we have 20, 30, 36 is a total sum. So we would start with a value of, that is our numbers. We will have our left sub-array and we would have a right one, or left partition, right partition. In the beginning, the left partition is going to be 0 and the right one is 36. Now, the sub-arrays must be non-empty, so this is not a valid solution actually, even though the difference is an even number, right? So this is not valid. So we have to iterate over the first number. So now left becomes 10, and the sum of the numbers in the left partition is 10. Now we have to subtract the 10 from our 36. So now this is valid. This is a valid difference. And we should return the number of those partitions. So our counter, our result, is going to be +1. It's actually just 1 in this case. Next, we run into the next 10. So now our left partition sum becomes 20, and our right partition sum becomes 16, since the 10 now belongs to the left partition. And again, we're going to increase our result to 2, right? So that's going to be result. Let's call this count, right? 0 because it's valid, then it goes 1 goes to 2. Next, we're going to run into a 3. So now the left partition becomes 23, right partition becomes 13. Now the difference between them is still going to be an even number, right? Because 23 minus 13, that's 10. So we increase our result by 1. Next, we add 7 to our left partition, so that becomes a 30. And what is 13 minus 7? I have to do some math. Is it 6? Right, so now the difference is still going to be even, right? And finally, we have 6, so this becomes 36 and 0. But this is not a valid partitioning because one of the partitions is now empty. And not because of the 0, but because we've exhausted all the elements. And actually, yes, because it's 0, because it's guaranteed that all elements have a value that is greater than 0. Right. So we could actually use that property if the sum of a left or right partition is 0 as a criterion to exclude that partitioning as a valid one. So I think we have a linear time algorithm and we have constant space because we just need to keep track of our counter. And I would now ask the interviewer if it's all right if I implement that solution. And then, of course, the interviewer will say, yes, that's perfect, awesome. Let's see how you implement this flawlessly. And off space for the sake of completeness. And now we're going to do the magic. So first, we have our left partition. We have our right partition. The left is going to be 0, and the right is going to be the sum of all elements in nums, right? And now all we need to do is iterate over all of the numbers in nums for n in nums. And yes, that is exactly what we will do. And now we will do left plus equals n and right minus equal n. So, and I'm just realizing that we elegantly skipped over the initial case that is not valid. So if we now do our little check, right? If the difference between left and right is an even number, so modulo 2, if it's 0, then we increase our counter. And I like to use the result as my return variable, so we'll have a result counter in this. Very end, we're going to have to return it counter. Right? So is there anything else to do? Well, I think we should go through an example and to see if we also catch the last case correctly, or if one of these values can become 0, which I think it does. And yeah, so we initialize left with 0, right with 36. Then we immediately, so this case will completely be ignored, so I'm just going to delete it. We immediately have this scenario, we have 10 and 26, blah, blah, blah. And then the last time we actually run into the problem where right becomes 0, right? So in that case, we have to also perform another check. So we have to check if right and right not equal to 0. Right, and I think that's all that is needed. So let's remove the comments and see if it passes the test cases down below. And it certainly does. In an actual interviewer, it's good practice to really pick one of those examples and step through the code with it. When it's a little bit more complex, you will easily find bugs that you implemented. I don't think there was a time where I've never had at least one small bug, an off by one error or missing increment. So checking the code with an example after writing the code always paid off for me. So I highly recommend that you do that. Now let's submit the solution to see if it passes all of the test cases. And it does. Happy days.